Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will deep dive into Red Hat OpenShift. So we will learn what is OpenShift, why is OpenShift the most used enterprise grade Kubernetes platform. We will try to understand the differences between Kubernetes and OpenShift. Along with that, we will also explore the OpenShift platform through the user interface as well as CLI. So this video is going to be quite interesting. Please try to watch it till the end. First things first, let's start with what exactly is OpenShift. Many of you might be aware about Kubernetes. So let's do a quick recap of Kubernetes and then let's move to OpenShift. So Kubernetes is a container orchestration platform where Kubernetes is used to orchestrate the containers. So to do a recap, when you have a application that you want to deploy as a container on the Kubernetes platform, so you create a pod for that one container or group of containers that you have. And a pod in Kubernetes is typically deployed using the deployment resource or replica set. And once you deploy your single pod or group of pods through the deployment, for the service discovery, you create a service in Kubernetes. And to control the ingress traffic, that is the incoming traffic for the containers within your pod, you create ingress resource. So this is the typical major workflow of Kubernetes. And on top of that, let's say your pod wants to read some configuration. So you create a config map. It can be something like the application properties or any configuration information that that your application wants to read. It can be as simple as a JSON data that your application wants to read during the runtime. And let's say this information is secure. So instead of reading a simple configuration information, let's say you want to read a API token or you want to read some password, a connection string to the database. In such cases, instead of using config maps, you use a secret. Additionally, definitely you will not have a single pod. Pod to pod communication is taken care by container network interface. So every pod or every container is typically attached with a container network, which is deployed through the container network interface, and communication can be established between your pods through the CNI. And for your pods to run, you have container runtime. And to make your pod secure or to make your containers secure, you also have additional things like network policies, you have admission controls in Kubernetes, and to make sure your pods are running and they don't go down, you also have pod disruption budgets, requests, limits, lot of additional things that Kubernetes provides as add-on or additional features. But the typical workflow of Kubernetes is something like this. And this workflow is quite robust. That means Kubernetes is a quite robust platform. It works very smooth. It is quite tested and used by a lot of people. But there is one thing that makes organizations. Let's say you're working in Amazon or you're working in a e-commerce organization which wants to deploy their containers at scale. There are two major things that make organization back out from Kubernetes and search for an enterprise grade offering of Kubernetes. Typically, Kubernetes is open source, free to use. Anybody can download them and start installing Kubernetes on their virtual machines. But what the open source version of Kubernetes lacks is the first thing, support. Let's say while using Kubernetes, you ran into an issue. That can be an existing bug with Kubernetes, which has a workaround, but you don't know how to implement the workaround, or you are not understanding how to implement the workaround. Or it can be some question with Kubernetes. Maybe your architect does not understand how to scale Kubernetes for a particular requirement. Architect has a question about it. Now it's quite difficult to reach out Kubernetes engineers immediately because it's an open source platform. So what you would do in this case, if you're using open source Kubernetes platform, is you go to the GitHub repository, you create an issue with Kubernetes and wait for one of the contributors of Kubernetes to respond back to you. Of course, that will eventually happen, but it is time taking. And enterprises might not prefer that. Second thing is the management overhead. Quite obviously, being an open source project, Kubernetes is not opinionated. That means Kubernetes does not tell you to use Kubernetes on Ubuntu virtual machines, or to use only CentOS, or to use only uh, Red Hat Linux. So it says you can install Kubernetes on any operating system that you want. These are the instructions, and you need to take care of the management of it. Let's say while installing Kubernetes on CentOS, you ran into an issue, or when you want to install Kubernetes at scale, where you have, let's say, 10,000 concurrent users, or you have application with huge resources. So then at some point, you will feel that managing Kubernetes clusters is quite tedious. So you might have Kubernetes clusters with 50 nodes, or you might end up with multiple Kubernetes clusters, each in different regions and availability zones. So at some point, you will realize it is a lot of management overhead as well. So these are the two reasons why organizations, probably second one is not a reason for everyone. If they have a proper DevOps team and SRE team, so this can be taken care. But the first one is still a problem. So because of these things, organizations look for enterprise grade Kubernetes. Now in the enterprise space of Kubernetes, they are nothing but, you know, companies which take the open source project of Kubernetes and develop their own distribution or their own flavor of Kubernetes. The first one in the list is Red Hat, which has an offering called OpenShift. And this is what we are learning today. Then you have EKS provided by Amazon. You have AKS provided by Azure. You have GCP provided by Google Platform. And then there are companies like Rancher, which have their own flavors of Kubernetes. So enterprises often look at these solutions. Of course, they are still using Kubernetes under the hood. Whether it is Red Hat OpenShift, EKS, AKS, GCP, or Rancher, they might not be directly selling Kubernetes to these organizations, but they are selling a flavor of Kubernetes. So they use the open source Kubernetes platform, modify it, and sell it to the customer with additional features as well as their own flavor. Now, when we get to Red Hat OpenShift, specifically about that, you will understand how many features Red Hat OpenShift provides on top of Kubernetes, which makes enterprises decide that, okay, this is the solution that I need. Because above Kubernetes, you are getting a lot of things. It's not just Kubernetes. Kubernetes plus support for the Kubernetes. Sometimes you get rid of the management overhead and a lot of added features. Now that we understood why companies look at enterprise offering of Kubernetes, let's focus more towards OpenShift. I will get to the OpenShift user interface in a while. We will explore the different options that you can use through the user interface. You will realize how rich is the Red Hat OpenShift user interface, because you can typically do everything that you do through the CLI and with a great ease. So now the thing is, coming to the OpenShift. So OpenShift has two offerings. One is the self-managed. Second is serviced. That is the managed services part. Now in the self-managed part of OpenShift, just like how you install and configure a open source Kubernetes project, similarly, you can take the OpenShift installer. Of course, OpenShift has an installer, which makes your life little more easy. And then there is something called RHCOS, Red Hat Enterprise Linux Core OS. I'll not go into the details of this installer and RHCOS, because typically it is more of administrative point of view and one-time thing. So we will take the installation of OpenShift probably in some other video. But you have a similar self-managed installation process of OpenShift, where you can install OpenShift on your own virtual machines. But the only condition is your virtual machines should have RHEL or the RHCOS. It has to be Red Hat Enterprise Linux. Now you come to the service or the managed offering. On all the top cloud platforms, if you take AWS, AWS has an enterprise offering of Red Hat OpenShift, the service based, which is ROSA. Red Hat OpenShift on, Red Hat OpenShift on AWS. Then you have Azure, where you have a service on the Azure platform, which is ARO, Azure Red Hat OpenShift. Similarly, you have on the Google Cloud platform as well as the IBM platform as well. So either you can use these managed services on of OpenShift on your cloud platforms, or you can go with the self-managed installation wherever you have your VMs on the on-premises or on the cloud platform, you can install it. Let me show you on the AWS platform very quickly. So if you go to AWS and search for ROSA, Red Hat OpenShift service on AWS. So you can just click on get started. By default, you will not have permissions to use ROSA. You have to enable ROSA explicitly, and you need to get the quota that is required if you are using a free tier of AWS, because OpenShift needs a lot of resources for it to be installed. By default, installation of OpenShift is HA, that is high availability. So the high availability of Kubernetes or OpenShift, you need to have 3 control plane nodes, and each control plane node, it is recommended that you have at least 32 CPU and 32 GB RAM. And number of worker nodes depends on you. You might have 3 worker nodes, 4 worker nodes, 6 worker nodes, which is quite common to have 6 worker nodes, or even more than that, depending upon your requirement. So the default option to install Red Hat OpenShift is through the HA configuration. So this is about the installation part of Red Hat OpenShift. What are the different things that you have? Additionally, there are things like SNO, which is single node OpenShift. So if you ask me, Abhishek, can I install OpenShift on a single node? Because I don't want the HA configuration, which is quite heavy, or my requirement is very simple. So if you have just up to 70 concurrent users, not 70 users, 70 concurrent users. That means 70 people trying to access your application or your platform at once, not more than 70. Then yes, you can use a single node OpenShift, which is called as SNO, where the control plane as well as the data plane are deployed on the same OpenShift node or the same node. But again, you need to have at least 64 GB RAM instance for it, and up to 16 to 32 CPUs cores, right? So this is the requirement. You can go ahead and install single node OpenShift as well. And apart from this, OpenShift also has something called CRC, which is similar to Minikube. Of course, it is not equivalent to Minikube. You cannot directly compare Minikube with CRC. But if you want to run OpenShift on your machine, just like how you run Kubernetes through Minikube or K3s or Kind, if you want to run OpenShift, you also have something called as CRC. Again, for the CRC, you need to have 32 CPU and 32 GB RAM. It also works with 16 CPU, but it is preferred if you have higher configuration. Finally, you also have something called as microshift. So these are the different offerings of Red Hat OpenShift. The reason why I'm trying to cover each of them is because you understand what are the different things, how you can install OpenShift and set up. Finally, you have something called microshift, which is used in the edge cases. So it is quite popularly used in the cases of edge computing. So if your organization is doing edge computing, or if you want to set up a edge based OpenShift instance, you can go with microshift. It is very, very light. You just need 2 CPU and 2 GB RAM. So these are the different things that OpenShift supports as of today. Fine. Now, the biggest question is, Abhishek, what are the things that OpenShift offers on top of Kubernetes? I want to understand that. So Kubernetes is plain vanilla model. As I've explained, it provides the things that we discussed in the first 5 minutes, whereas OpenShift can be understood as Kubernetes plus advanced features. For example, OpenShift has inbuilt CI/CD. OpenShift has inbuilt networking. So when you install OpenShift, by default, it comes up with Creo, and you can also set up overlay networking, like OpenShift comes with SDN, lot of other things which are quite good for enterprise organizations to start with. So the container runtime is Creo, and it also has a networking, like just like Calico or Flannel, there is something called SDN, which is default in OpenShift. On top of it, OpenShift also comes with inbuilt observability. So you don't have to set up monitoring, or you don't have to do a lot of installation for the monitoring, because OpenShift has default observability. OpenShift has GitOps that is out of the box. You just need to enable it. OpenShift has advanced user management. So you can easily integrate your SSO or your Active Directory that you have with OpenShift. On top of that, OpenShift has something called as operators, which is my favorite feature of OpenShift, because you can install hundreds of Kubernetes controllers or even custom Kubernetes controllers through this operators of OpenShift. And installation, you can do it through the Helm chart as well. But when I move to this operator section, you will realize how it can make your controllers immutable. So we will get to this point, and we will also deep dive into operator lifecycle manager, which is again available out of the box on your OpenShift clusters. And above this, you have a very rich user interface, something that you see here. Of course, user interface is also available for EKS, AKS, but the user interface of OpenShift is very, very rich, and it cannot be compared with any other managed offerings. So these are some of the things that Red Hat OpenShift provides on top of Kubernetes. Of course, you have the installation management that is made quite easy in OpenShift using the machine sets, machine configuration. Uh, so there are other things like machine set, machine configuration, which we will cover in the administration part of OpenShift some other time. Now let's go to the OpenShift platform, because I have been talking quite a lot about the advantages that you get through OpenShift. Let's explore them using the user interface. If you want to try OpenShift, like I said, you can go to AWS and create a ROSA instance, or what you can do is you can search for OpenShift Sandbox. So developer sandbox for Red Hat OpenShift. Go to this, start your sandbox for free, and you can get Red Hat OpenShift for 30 days. So you can use Red Hat OpenShift free for 30 days, but it will not have all the administrative privileges that you see here. You can get a feel of Red Hat OpenShift. If you want to try it completely, like you want a dedicated Red Hat instance for yourself, then you should either go with ROSA or ARO, because they are managed offerings. You don't need large instances. Cool. So what's in the Red Hat OpenShift user interface? Like why I was talking more about it and why I was saying it is very rich. So if you go to the workload section, you can get a list of running pods. So these are the pods that are running in different namespaces. By default, OpenShift has a lot of namespaces, not like Kubernetes, where you just have a kube system namespace, which will have the default Kubernetes workloads. But in OpenShift, you can see these are the number of namespaces that are available out of the box. Each namespace has a significance. For example, if you look at the OpenShift router namespace, let's search for. So there is this namespace called OpenShift Ingress operator. So this OpenShift Ingress operator, which is out of the box, what it does is it sets up a Ingress controller for you. You don't have to do anything. You just need to install OpenShift, and you have this namespace installed for yourself. And within the namespace, there is an Ingress operator. And if you search for Ingress namespace, you have the HA proxy router running out of the box. So the default Ingress controller in OpenShift is HA proxy. Of course, you can change it. you can use traffic, you can use Nginx ingress controller, you can use any other ingress controller, but the default one is HA proxy. So these are the HA proxy things that are already running on your Kubernetes cluster. You don't need to install ingress controller. So going back, you can see the different pods that are running. You can manage the pods through this user interface, typically deploy, edit, whatever you would like to do. And then there is something called deployment config, which is very specific to OpenShift, similar to deployments, but there are few additional things. You can manage your stateful sets, secrets, and config maps. Of course, you can do this in the EKS as well, but you have more things which I was talking about, something like the observability tab. So OpenShift comes with default observability setup. If I look at alerting, or let me show you the metrics. So I can directly insert a query, just like the PromQL query, and I can get insight of the metrics of the running pods on my cluster. And you can also get the dashboards. Let's say you want to get a dashboard for the Kube API server performance. So you already have the dashboard here. You don't have to set up Grafana for it, or you don't have to set up all the required things for dashboards. You can change any of the API server component here, or you can change it to pods. Let's say I'll change it to Kubernetes pods in namespace, and you can provide your namespace. Let's say my namespace is one of these. Let's take OpenShift console. So you can see the CPU utilization of the pods in your OpenShift console namespace. You can get a graph of it, historical usage of the CPU by your pods, and you can also set some targets. So everything that you do with observability, alerting, metrics, tracing, as well as dashboards. And the user management part. This is very, very important. Like when you're working in an enterprise, it is important that you have your Kubernetes clusters or your OpenShift clusters tied to an SSO, because you cannot grant permissions to each and every user, right? So if you already have a Active Directory, or if you have an LDAP, or if you have a identity provider, what you can do is you can go to the user management section and you can tie up your IDP. See, add IDP. You can add your OAuth configuration. Let's say I'm using Okta. I can tie up my Okta configuration here, provide the redirect and everything. And then your OpenShift cluster is tied up with that SSO. It's very good, right? If you tie up your SSO with OpenShift, developers can only get to see the developer section. Right? Till now, I was using the administrative tab, but if someone logs in with developer privileges, this is what they can see. They cannot see the compute related things. They can only see the observability. They can see the builds part. They can see the config maps and some secrets that they have RBAC permissions with. Going back to administrator, not only that, you can manage resource quota through the UI, limit ranges, and custom resource definitions. So in the custom resource definition, you can create any new custom resources through the API and manage their lifecycle. My favorite part of the OpenShift is the operators. So if any of you is not aware what is operators, let me take 5 minutes here to explain operators. And OpenShift takes operator to the next level because it also comes with something called operator lifecycle manager. Operator lifecycle manager is an open source project. It's not the only Red Hat OpenShift thing. You can also use operator lifecycle manager, but Red Hat OpenShift comes with default out of the box OLM. Okay, it might go out of the head for you if you are not aware of operators. So let me start with that. What is a operator? In Kubernetes, everything or most of the things is controllers, right? Whether you are installing Argo CD on Kubernetes or OpenShift, or whether you are installing Istio, or you might be installing any other thing like your service mesh, like Istio or any other thing. End of the day, Prometheus, Grafana, everything is a Kubernetes controller. There are different ways to install the controllers, right? So you either install the controllers using the plain YAML manifest. So if you go to Argo CD, you can find the plain YAML manifest, you can install through it. Or you can install the controllers using Helm charts. Additionally, there is another way of installing controllers, that is through operators. You might be aware about manifest and Helm charts, but operators way of installing Kubernetes controllers is very, very robust. Why? Because what an operator does, when you install a controller, let's say I have installed Argo CD through the operator, and for some reason, some bad user or a bad actor or someone who does not know completely about Argo CD goes to the config map of Argo CD and updates a very important property of Argo CD, which might break the installation or which might create issue with the Argo CD itself. But because they have permissions to config map, they have modified it, right? So what happens is operator will not allow this modification. It will say that no, you are not supposed to do it because the configuration that is provided to me is not something like this, right? So operator will auto heal this, just like what GitOps does. Operators continuously monitor the state of the controllers that they have installed. It can be config maps, it can be secrets, it can be pod.yaml, anything. And if someone, a bad actor, is trying to change something in the in the controller, they will get rid of that change. I'll give a quick demo as well. Let's go to Red Hat OpenShift. Go to the operator hub, which has list of operators. Typically, you can install any Kubernetes controller through this operator hub. Let's search for Argo CD. Okay, or you can simply search for GitOps. So you have something called Red Hat OpenShift GitOps, which is an Argo CD offering provided by Red Hat OpenShift. This will install Argo CD for you. When I click on install button, so it will just ask you for things, which version of Argo CD do you want to install, XYZ. Click on the install tab. Now what it will do, what this operator will do, it will install Argo CD for you. And in a moment, once it is installed, I'm going to modify a config map of Argo CD, the default Argo CD config map, which has all the properties of Argo CD. You will see that this operator immediately overrides that change. So what you will get with that, something that you don't have with manifest or Helm charts, where if you install and if you try to change anything, a bad actor or even yourself without proper knowledge, then that change will be there. It might affect your installation. Now imagine if you are installing your OpenShift nodes through the operators, or if you are installing your Kube API server through the operator, which is what happens in OpenShift. Everything is installed through operators in OpenShift, right? So because of which your infrastructure or the important configuration of your OpenShift will stay immutable. So the immutable infrastructure or the immutable configuration is one of the very important advantages that you get in OpenShift, which is powered by operators. I hope the installation is successful. Let's see. Perfect. Now Argo CD is installed. Because I use it on a day-to-day basis, I know Argo CD is installed in a namespace called OpenShift GitOps. You can see there are two namespaces, right? When I search for GitOps, one is OpenShift GitOps operator and second one is OpenShift GitOps. This is the namespace where the operator resides, right? This operator. This is the namespace where operator resides, and this is the namespace where my Argo CD controller resides. Now, if I go to this namespace, go to the workloads, and let me update Argo CD config map, YAML, and what I will do is one of the important configuration. Let's try to update it. I will change admin enabled from true to false. Okay, let me save this, and immediately you see this object has been updated. Let's reload and let's look at admin enabled. We changed it to false, but it is true back again. Again, let me update false, save it, and the moment you do it, you will see the object has been updated. Reload, again it goes back to true. You can try this with the node configuration, anything on the OpenShift container platform, which is deployed using the operators, and your changes are reverted back. But then you might be wondering, then Abhishek, what if I have to make an actual change? Like, we were talking about bad actor who is trying to change admin.enable, but what if I really want to make change to this particular field, right? Sometimes you want to update the Prometheus pod configuration or GitOps pod configuration. In that case, when you install that controller through the operator, what you need to do is you should go to the operator. For example, this was the GitOps operator that we have installed, and you need to modify that through the custom resource provided by the operator. You need to get used to operators to understand more about this particular thing. So when you install a operator will have something called as operand. So for GitOps that we have installed, this is the operand which has the YAML configuration. And in this YAML file, I need to update that disable the admin privileges or enable the admin privileges. And every operator will have a documentation. For example, GitOps operator documentation. So when you search for that, you will find a documentation for the GitOps operator. And within that documentation, you will find the steps on how to disable it. So similarly, Prometheus operator or any other thing. Of course, if you are new to operators, you might be finding it little difficult at this point. But once you get used to operators, you will really love how they function. And typically, you can install anything through the operators. If you go to Operator Hub one more time, and you can search for, let's say, Prometheus. See, you have a Prometheus operator, or you can search for anything that is in the AWS. So you have these many operators of AWS. Of course, there are few things which might not have operators where the community or Red Hat is still working on developing those operators, because the operator in Kubernetes has to be written by someone, right? If you're talking about Argo CD operator, which is something Red Hat and other companies are working on, or the open source community of Argo CD is working on. End of the day, it's a Go program where you need to write that application in Go or other ways. Okay, going back. Now, what is OLM? You like things about operators, you will love when you learn about OLM. So OLM, what it does is it's a operator lifecycle manager. Okay. Previously, we installed GitOps through the GitOps operator, right? At some point, there will be a new version of GitOps operator, right? Probably GitOps operator now is installing GitOps through Argo CD, and let's say it installs one dot um, uh, what is the latest version? So 1.12 of Argo CD, let's say. Okay, I don't remember it back of my mind at this point, but let's say 1.12 version of Argo CD. Some point there are changes to the GitOps operator. People who have developed this operator, and the new version of GitOps operator, let's say it installs 1.13 or 1.14 XYZ. Okay, so the latest version is I think 2.13. So it installs some version. Now what happens is operator lifecycle manager will allow you to upgrade the operator that you have or manage the operators. It can be update, create, delete through a single button. So you don't have to again bother about upgrading your operators, maintaining your operators, because you have something called as operator lifecycle manager. If you go to the installed operator section, tomorrow, if there is a new version of this operator, just if you go to the subscription section and if you set update approval as automatic, you will not even know that a new version of operator is updated. So it is taken care automatically through OLM. You can also configure it to manual, because some organizations might want to monitor that, okay, I don't want a new version all the time. I want to monitor it. So you can just set it to manual, and whenever there is a new version, you can see here that there is a new version. If you want, you can upgrade. And upgrading is again a click of a button. You can just upgrade. So this is about operator hub and installed operators and OLM. So this is a very, very rich feature that you have in OpenShift. I'm not saying you cannot do it with Kubernetes. You can definitely install OLM in Kubernetes and you can do typically everything that I've shown here. But this comes out of the box in Red Hat OpenShift. So we were talking about the observability, user management, administration. Let's talk about the builds thing. So you can have automated CI pipelines that are set up, and you can have automated container registry as well. If you're using EKS, you can use the AWS container registry, right? ECR, Elastic Container Registry. Similarly, with OpenShift as well, it has an inbuilt container registry, and you can have inbuilt CI plus CD. The default CI solution is Tekton, and the default CD solution is Argo CD. All that you need to do is again go to the operator hub. If you want CI, just click search for Tekton, builds for OpenShift. You need to just enable this operator, just like how I enabled the GitOps operator. Now, once you enable both of this, you have a CI solution on the OpenShift platform itself, and you have the CD solution on the OpenShift platform itself. So it comes with out of the box CI CD solution as well. You can explore more about OpenShift. Like there are many things that we can deep dive and talk about, but I want to give an introduction to OpenShift and explore the most important features. So if you click here, you will get copy login command, and you just need to provide the password that you try to log in. Let me just provide the password. So once you provide the password to log into your OpenShift container platform, then you will see a display token. You can just copy it and take your terminal. So this is my terminal, and I can just type the login command that I have, and you will be authenticated to the OpenShift container platform through the CLI. Okay, it said certificate sign failed. So if you just search for OC login, there is a way to ignore this. I don't remember the syntax back of my head, so I will just search for this insecure, right? Because I don't have that certificate on my machine. So I'll just pass insecure skip TLS verify to true. And that's it. I am authenticated with that OpenShift container platform through the credentials that I've shared in the UI. If I have kubeadmin access, now I am logged in here using kubeadmin. If I have a developer access, I will be logged in with that particular developer account. That's why SSO integration is important. Once you have the SSO integration, every user can go through the same process. They can get their OC login command, just like how we got here, and they can execute it. So this cluster will be deleted in next 30 minutes. So even if you try to log in with this particular OC token, you will not be able to do it because the cluster will be expired. I've just created a cluster for 4 hours. Perfect. So once you have this, now you can do typically everything that you do with kubectl, but OpenShift has something called as OC, which is OpenShift client library. I hope the definition is right. So you can do exact same things like OC get pods or OC get pods -a, which will list out all the pods on my OpenShift cluster. But additionally, OC has few more things, right? OC has everything that kubectl has, but on top of that, OC has more things which you can search using OC-h. So in the help command, you can see you can do the administrative related things. You can do the auth related ones. It has an inbuilt registry that I was talking about. You can create a proxy for your container registry, right? You can create many other things using OC. You can just do OC who am I, and you will see that you are logged in as kubeadmin. It is preferred to use OC instead of kubectl if you are using an OpenShift cluster. Like I said, there are more commands and you can get better experience if you are using OC. To install OC, you need to create an account with Red Hat and just search for install OC for Windows, Linux, or macOS. Then you have this networking tab, and within the networking tab, along with Ingress resources, you can see one more thing called as routes. Now, what exactly is routes? So you can consider routes as Ingress equivalent in OpenShift. So routes is similar to Ingress, but routes have rich TLS configuration. That is, in case of Ingress, when you want to configure a secure Ingress using the TLS configuration, so probably you will be using some certificates and you might be using some annotations which will make your Ingress secure. So you will be providing the path for your certificates or how your load balancer should handle the Ingress traffic. In terms of routes, it is more simplified because in the routes TLS configuration, you can create 3 types of secure routes. For example, if you see here, the GitOps controller that we have installed, it has something called as GitOps server, which is the Argo CD server. And if you look at the YAML file of this route, you can see the host is specified just like Ingress, and service is also specified just like Ingress. Then there is one tab here or one field here which says TLS termination as re-encrypt. So in the world of routes, when you are dealing with secure routes, you have 3 different kinds of secure routes. One is edge termination. Second is re-encrypt termination. So you can just say that I want this kind of termination. I will explain what they will do. So you have edge termination, re-encrypt termination, and pass-through termination. So what exactly they will do is, let's say you have a client. Okay. Client is nothing but, let's say you have a user, and this is your pod that is deployed on OpenShift. You have Ingress controller, which is HA proxy in this case, right? In the world of OpenShift, by default, it is HA proxy. Now, what does edge termination mean? Is when the client is trying to reach the HA proxy, this communication will be secure. Whereas the traffic that flows from the load balancer to your pod will be plain traffic, that is non-TLS traffic. So this is about the edge termination. Whereas when you say that my termination has to be re-encrypt, then that means it is even more secure, where the traffic from the client, sorry, to the load balancer is secure, which is TLS traffic, and the traffic from HA proxy, the Ingress controller, to the pod is also secure, that is TLS, right? So in terms of edge, TLS traffic from client to the Ingress controller, and from the Ingress controller to pod, it will be plain traffic. Whereas in terms of re-encrypt, it is secure traffic, TLS traffic from client to HA proxy and from HA proxy to pod as well. Finally, you have pass-through. In terms of pass-through, as the name itself suggests, client will pass through the load balancer. So the load balancer will not interrupt the request. It will just pass through the load balancer and directly reach the pod. And at the pod, you can handle secure traffic. Or for the pod, you can just attach a certificate so that client can communicate with the pod through the certificate. So literally, load balancer is passed through. Load balancer will not come into the picture. So that is about the pass-through traffic. So you have edge termination, re-encrypt termination, and pass-through termination. All that you need to do is you just provide that in the termination section. When you provide the termination section, it will handle if it is edge, re-encrypt, or pass-through. When you deal the same thing with Ingress, you will need little more configuration, because in the world of Ingress, different load balancers handle in different way, and typically it is handled through the annotations. Such rich configuration is not available. Let's try to do a demonstration where I will create an application. I will create the service for that application, which is deployed as a pod, and then we will create an OpenShift route for it. And we will see how the route configuration is read by the Ingress controller, how we can access the application publicly. For that, we will use combination of UI as well as CLI. Now that we know how to use both of them. So first thing is I will go to the deployment section and click on create deployment. I'm using the default namespace. You can use anything that you would like to. So there is a sample deployment file that is provided when you click on YAML view. You can ignore that. And I will provide a link in the description where I have the deployment service and route configuration within a document. You can also use the same thing. So this is the deployment. It's a sample GIN application with 2 replicas of the pod. And if you don't know what is quay.io, here if you see, instead of Docker, I'm using quay.io. It is similar to Docker Hub, but this is completely open source and free because in Docker, there is a rate limiting issue. People also use Quay where there is no rate limiting issue. Click on create. Okay. Instantly, I have 2 replicas of the pod that are running. Click on the pods. Perfect. I have 2 pods running. Now let's try to create service for it. And service, we will try to do it through the CLI. So again, I will copy the configuration, the YAML file. And what I'll do is in the CLI, let me create something called gin app.svc. Sorry, gin app.svt dot hyphen svc dot yaml. Of course, the name doesn't matter, but just for the purpose of understanding, because I'm copying it from the UI, these are the fields of the created service. I'll just remove them. All that we need is basically, so I'm copying this from another cluster where the service is already there. So all that we need is important things, namespace. It has to be default, right? And then cluster IP is not required. It will be auto created. You need to make sure that the port and target port are correct. I have made sure the port is same for the container that is deployed. Selector should be same as the pod, and then type is cluster IP. So let's do OC apply hyphen F gin app svc dot yaml. So it should create service for us. If we do OC get svc, we should see the gin app service. Perfect. It is cluster IP. That's why you don't have external IP address. Now the final thing is to create a route. So to create a route, we can use CLI and we can use this simple command OC create route. Edge is the termination that I have explained. Hyphen FN service, the name of the service. And this is another important section. Insecure policy is redirect. What does this mean? This means, let's say you have Amazon.com. By default, Amazon.com is HTTPS. But what happens if you try to access it HTTP Amazon.com or HTTP Google.com? Automatically, your request is redirected to HTTPS. So who is doing that? That is done by the load balancer. When it receives the HTTP request, it can automatically convert that to HTTPS, but you need to explain it. In OpenShift, through the route configuration, this is the field that explains. When you say insecure policy as redirect, that means if someone is accessing on HTTP, redirect the request to HTTPS. Now, as soon as the route is created, who is taking care of it? Like in the OC create command, I haven't provided any host name or I haven't provided the uh, any other configuration, right? But who is receiving this route request? It is received by the Ingress controller. And like I explained, in OpenShift, the Ingress controller is HA proxy. So HA proxy will receive this request. We can see that if we go to the Ingress namespace and if we look at the pods, they will update the HA proxy configuration file. Just like you have nginx.conf file, in HA proxy, you have haproxy.config file. So if you exec to any of these pods using the terminal or through the CLI, there is a file here called haproxy.conf file, right? This one, haproxy.config. You can just do cat on this file and grep through the address. So if you do OC get route, you can see the host name that is assigned to your route. And when you just do grep on the HA proxy configuration, you will see how load balancer is forwarding this request to the pod. So you can see when I search for HA proxy configuration file against the GIN app, you can see it is saying the request is forwarded to this particular pod 10.129.2.41 and 10.131.0.70. What are these things? if you do OC get pod -w wide, sorry, -o wide, so you can see these are the IP addresses: 10.129.2.41, 10.131.0.70. So when you are trying to access this particular application on the load balancer IP address, then the request is forwarded to this particular pod or this particular pod on the round robin approach. Let's see if that is correct. If I take this particular thing, host, and if I do curl on it, so I am doing curl on HTTP, right? I'm not doing HTTPS. So curl is redirecting the request. You can see the output when you provide -l, which is saying curl to provide the redirected output also. So it will give you the output that the application has. Just do -k, sorry, -k. See, you got the output as hello. If you directly give HTTPS instead of -l, okay, if you directly provide HTTPS, which I am going to do it here. So you got the output directly as hello. You can also try it through the browser if you are interested. So it says the connection is insecure. Let's accept the risk. And you got the output, the JSON data, or you can also look at the raw data. So this is the demonstration. You can try with Edge, you can try with re-encrypt, pass through, and also explore different options that are on OpenShift. Thank you so much for watching today's video. I hope you found it useful. If you want me to make a video on any specific feature of OpenShift, do let me know in the comment section. I will try to do it. See you everyone. Take care. Bye bye.